أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. My fourth year students, the lecture on ANOVA has earlier been shared with you in PowerPoint format, but I don't think this ANOVA is that much simple that you will understand from the PowerPoint. So this is the ANOVA with proper explanation. And the word ANOVA is derived from the analysis of variance. What is ANOVA and how do we define? This ANOVA is used to compare the means of two or more independent samples. Two samples, when we compare the two means, we use the t-test. So we use this ANOVA when we are comparing more than two independent samples, that is 3 or more, and we test the differences, whether the differences between the means are statistically significant or otherwise. So we use in ANOVA, the test that we use is known as the Fisher test, also known as F test, and the distribution is known as the F distribution. What are the uses of this test? I am repeating the words, that is ANOVA compares the mean between the groups when there are more than two groups. For example, you could use a one-way ANOVA. One-way ANOVA. Why this test is known as one-way ANOVA? I will explain later on, inshallah. You could use a one-way ANOVA to understand whether exam performance differed based on test anxiety level among students, dividing students into three independent groups, that is the low, the medium, and high stress students. This one-way ANOVA is an omnibus test, a statistic, and cannot tell you which specific group. For example, we are comparing group 1, 2, 3, 4, 5, and so on. Then this ANOVA statistics tells us that there is a difference between two means, but cannot tell us which specific group was statistically significant. And then to determine that is which specific group or which mean was different from the other, we use another test which is known as the post hoc, और मेरे ख्याल में इसको two-way ANOVA भी कहते हैं. So then we use another test which is outside the scope of this lecture and this module. Hypothesis testing in ANOVA. ANOVA tests the null hypothesis that samples in all groups are drawn from population with the same mean values. Over here applies the central limit theorem. Central limit theorem के कुछ conditions थे, वो मैं पढ़ा चुका हूँ इससे पहले. There is no need of repetition. These are repetition of when there are only two means, we use t-test, and if there are more than two groups, 3 or more, then we use the F test or ANOVA. There are 6 assumptions for calculating ANOVA. Number 1 is your dependent variable. By now you must know the difference between dependent and independent variables. Your independent variable should be measured at the interval or ratio level. Assumption number 2, your independent variable should consist of 2 or more categorical independent groups. Assumption number 3, you should have independence of observations, which means that there is no relationship between the observation in each group or between the groups themselves. For example, there must be different participants in each group, with no participant being in more than one group. This is actually more a study design. Example of this assumption is that if we want to conduct a study on the students of NMC, and we make 4 groups, group 1, 2, 3, 4. Group 1 is for say first year, 2 second year, 3 third year and fourth year. 4. Now the first year student cannot be represented in fourth year, and fourth year student cannot be represented in or cannot join the third year. So no participant is being in more than one group. So every student will be in his own group. Assumption number 4, there should be no significant outlier. What is outlier? We already know. Assumption number 5, dependent variable should be approximately normally distributed for each category of the independent variable. And assumption number 6 is there should be homogeneity of variances. These are actually the conditions of a central limit theorem. The summary of these 6 assumptions: the population must be close to a normal distribution. This is actually the condition of central limit theorem. Variances of populations are equal. Again, the central limit theorem. Responses for a given group are independent and identically distributed to normal random variable. Samples must be independent and group must have equal sample sizes. What does this test do? That is, what does ANOVA do? ANOVA compares, we say that the null hypothesis say, this is null hypothesis, that is the mean of group 1 is equal to mean of group 2, group 3, group 4, and K is the number of groups. How many groups are there in your study is the K represents the number of groups. Now, null hypothesis say in calculating ANOVA that there is no difference between the means of the different groups. So there is no difference between the means of say, group A, group 1, group 2, group 3, group 4, and so on. Now, the ANOVA actually measures the distance between, or the ANOVA is the ANOVA represented by F, or the F distribution, or the F test basically measures this is actually the ratio between the variance between the group and within the group. So F distribution is actually the variance among the group and around the group. So this is actually a ratio. For example, in this group, if this is the mean, this central line. Now, what is the difference of different individual entries with this mean? This is known as the between. And what is the difference of this mean with this and this mean in these 3 groups? This is known as variance within or around. So the Fisher test or F test is the variance between the groups and variation within the group. Study design. Recruit a group of individuals and then randomly split this group into 3 or more smaller groups. That is, each participant is allocated to one and only one group. I am repeating my words. If we take the NMC students and take 3 or 4 groups, say first year is group 1, second year is group 2, and so on. You then get each group to undertake a different task or put them under different conditions and measure the outcome or the response on the same dependent variable. For example, we wish to know whether different teaching strategies at Nowshera Medical College affect the group to complete a task. We can measure the outcome which is known as the dependent variable. Now, this is a study design. The students of NMC are selected for a study to be conducted in Nowshera Medical College. We divide these students into three different groups. Say this is group A. Over here means A means group. Now, group A1 means these are the students of first year are labeled as group A1, second year group A2, this is second group, and this is third group. We take NMC students of first year, second year, third year as three groups. So, all these are independent groups. No student of second year can join the third year, or he cannot be represented in first year or third year, and vice versa. Now, how to calculate ANOVA or F for this study. So, F is basically the ratio between the mean square between and mean squares within. How do we measure the mean squares? This is the formula for calculating. This is the same formula for calculating, that is, we were calculating the variance. A square means variance, summation of x minus x bar squares by sample size minus 1. Now, this A1 is say students of first year, this is A2 second year, A3 third year. They were taught some subject, say for example physiology, biochemistry, anatomy, whatever module it is, and they were then assessed. The scores of 6 students taken from first year was that 6 out of 15, 8 out of 15, 4 out of 15, 5, 3 and 4 out of 15. In second year, again 6 students were taken from this group, and they scored 8 out of 15, 12, 9, 11, 6 and 8 out of 15. The third year students scored 13 out of 15, 9, 11, 8, 7 and 12 out of 15. So, we take 3 groups, that is more than 2 groups. We can take 4 groups, 5 groups, 6 groups, and so on. Now, what is the mean of this first year assessment? Y bar 1 represents the mean of this group 1. This is 5 calculated over here. This y bar 1 is equal to summation of all the 6 values divided by the number, and this is coming out to be 5. Now, y bar 1 is 5. Similarly, mean for this group is y bar 2, and this is actually summation of all the 6 entries by the number of entries, and this is coming out to be 9, and similarly the third one is coming out to be 10. Now, this was step number 1, to calculate the mean within each group. Mean within each group. Now, step number 2 is calculate the overall mean, that is mean of all these 3 groups. One method is that 6 plus 8 plus 4 plus 5 plus 3 and all these divided by the number of entries, which is 18. And another method is summation of these all y bar 1, y bar 2, y bar 3. This one, y bar 1, 2, 3 divided by the A represents the A is the number of groups. A represents the groups. So, A, the number of groups is there are 3 groups in this study. Now, this is 5 plus 9 This is y bar 1, y bar 2, y bar 3. 5 plus 9 plus 10 divided by 3 is equal to 8. Now the overall mean is 8. Step number 3. Calculate the between group sum of square differences. Sum of square differences. So the sum of square differences is measured by the x bar 1 minus y. This is just like the x minus x bar that we were doing in calculating our, this is calculating variance. So the an older lecture of mine for the calculating standard deviation. This was we had discussed in measures of dispersions. So that one is actually this square of x minus mu or x minus x bar square. So this one is actually the, that is this one. As there are 3 groups, so we will sum up this y minus y1 bar minus y1 bar is this 5 and y bar is this 8, that is mean of all these groups. Now the plus number of n means sample size, which is 6 in all these groups. 6, that's this in this A1 group, A2 group and A3. Now we calculate these, that is summation of all these squares, y bar minus y bar 1 2 3 minus y bar, the squares. When we calculate, this is coming out to be 84. And over here n represents, this n represents the sample size, and in these cases sample size is 6 in each group. Now the between group degree of freedom, between group degree of freedom, between group degree of freedom is, this is frequency between, we know that there are 3 groups, A1 2 3 and minus 1 is the, for calculating V minus 1 from the sample size, and this is coming out to be 2. Now so the between group mean square value is, between group mean square value is, that is, this is the between group square means, that is 84 by the sample size minus 1, which is 2, and this is coming out to be 42. Now we have calculated the this mean square between. We have calculated this mean square between. Now we will calculate this mean squares within. Step number 4 is calculate within group sum of squares Now the within group sum of squares for this group A, as we know that calculating the variance is actually summation of x minus x bar square by the sample size. This is formula already discussed in calculating standard deviation and variance. Now we will calculate in this way. 6, 8, 4, 5, 3 and 4, these are the entries of this group, and we want to calculate the difference, which is 5 is the mean for this group, 9 is mean for this group and 10 is mean for this group. which we labeled earlier as 5 as the y bar 1. This is this one. This is y bar 1. Mean of this is known as the y bar 2, and of this one is known as the y bar 3. Now, in the same way, that is x minus x bar. Now, this 6 is x or say y, and minus 5 is the y bar or x bar. Over here, we labeled these entries as y instead of x. Now, 6 minus 5 is equal to 1, and this one 3, 1, 0, 2 and 1, and similarly in these cases we subtract the mean from the individual entries, and these are the outcomes: 1, 3, 0, 2, 3, 1 in this case, and in a 3 group this 13 minus 10, 3 and 1, 1, 2, minus 2, minus 3 and 2. Now, we will take squares of all these in this way, and then we'll sum up this. Sigma means summation of all these squares. Now, 1 square, 3, this is summation of within. These are the squares of these values: 1, 3, 1, 0, 2, all these. We sum up all these values in the same way as we were calculating for calculating variance, and this is coming out to be 68. Now, within the group degree of freedom is, as we know, for calculating degree of freedom is the n minus 1, but over here n is actually the number of sample size, that is the sample size, while in which in this case is a total of 18, but there are 3 groups. So, the number of the groups multiplied by the sample size. So, the number is 3, that is 3, this one, and sample size is 6 in each group, this group, this group and this group. Now, 6 are the entries, minus 1 when we calculate, this is coming out to be 15. Thus, the within group mean square value is, mean square within the group is summation of within by the frequency or the degree of freedom. This is 68 divided by 15, this is almost 4.5. Now, we have calculated the mean squares within, between, which is 42, and mean squares within, which is 4.5, and we know that if ratio is equal to mean squares between and mean square within, 42 divided by 4.5, this is almost 9.3. Now, how to interpret this 9.3? This this study of students of NMC that were taught some subject and then were assessed in that subject, and in order to see the mean, compare the means of their performance of the 3 classes, that is first year, second year and third year. The calculated value is 9.3. What does this represent? Now, the critical value is the number that the test statistic must exceed to reject the null, to reject the test. In this case, for if distribution of this 2 is the degree of freedom and 15 is the degree of freedom, this 2 is the degree of freedom of 1 and a 15 is df2. When we consult this F distribution table, this is actually a more focused slide of the previous one. This is the same 9.3 value. The critical value is the same sentence. Critical value is the number that a test statistic must exceed to reject the test, In this case 2 and 5 for the 2 and 5 for the uh, um, degree of freedoms. Now, if we consult the F distribution table or F values for alpha 0.05, now we will see this F distribution table, or a more focused one is this one. Now, for F table for alpha 0.05, what is the difference between alpha and p value? You must know by now. I have explained these earlier. Alpha is a fixed one before the calculation, and p value we get after the calculation. Now, for alpha 0.05 or this confidence interval, this is degree of freedom of 1 and degree of freedom of 2. Now, our degree of freedom, first degree of freedom of or the df1 was 2. Do you remember from this slide? df1, this is 15 is df2, and over here was this one, 3 minus 1 is df1. Now, we will see the F table for these values. Now, df1 was 2 in our case, and df1 was 2 and df2 was 15. Now, the value which is coming at the intersection of these two degree of freedoms is 3.68. More focused in, more clear in this table. This is df2 df1 and 15 df2. These two intersect over here, and this 3.68 is the critical value. Now, how to explain this 9.3, which was our test statistics? We know that if our test statistics crosses the critical value, we can reject the null, and the critical value over here is 3.68, and 9 means that we have already crossed this 3.68 at alpha 0.05. The results are significant at 5% significance level. We can reject the null hypothesis, concluding that there is strong evidence that the expected values in the 3 different groups is there, and the p value calculated for this, although we have not calculated for this study, but the p value calculated for this group is 0.02, which means that you must know that 0.002 means there is a very strong significance that we can reject the null hypothesis. After performing the F test, it is common to carry out some post hoc analysis of this group means. That is, now we know that there is, coming to the null hypothesis, this one. This null hypothesis in this study, in our study, that is the study of the students of NMC for say first year. This is first year, mean of first year, mean score of first year, mean score of second year and third year. Now, the null hypothesis say that means of these which were in this case was 5, in this case was 9, and over here it was 10. Now, the null hypothesis say that all these means are the same. while alternate hypothesis say no, there is difference between 5 and 9 and 10, and we proved that there is a significant difference between these means. Now, which group is greater and which is lesser? This does not tell us this study or this ANOVA does not tell us which group is more than the other group, and for this purpose we will have to conduct a post hoc analysis, which again is not in the domain of this module or your fourth year. So that's all for today regarding the ANOVA. मेरा नहीं ख्याल कि इनोवा इतना सिंपल है और इतना दिस इज़ क्वाइट डिफ़िकल्ट टॉपिक, और this online lecture cannot be a substitute for the lecture in class, but anyway we are supposed to do so. And again, if there is any problem, you listen to this lecture again and again, and you will inshallah understand. Thank you very much.